Hi there, my name's Nev and I'm a teacher of Year 11 and 12 Maths and Computing in Sydney. Now, if you've ever wanted to track an animal or track a human and wondered how to do it, here are some tricks. I actually have some humans from my class and we're just going to analyse the displacement, velocity and acceleration as we run across this basketball court. So from that footage, well, I'm actually going to use slightly different footage, I can go to After Effects. Now actually with the After Effects I'm just going to use the bike here because it's a bit smoother, and because I'm wearing this red hat I can grab a motion tracker, put it on the red hat, and it can, whoops, didn't stick. We've got to whoa. Anyway, I'll show you the detail of this in a later video. No, it's not working, but I can track that motion and send the coordinates of that red hat to an Excel file. Let's have a quick look at what that can look like. I've put superimposed a ruler and I've attached that arrow to follow the hat. Now when we get that data we can paste it into Excel. It automatically gives us our frame size that we're using, 1920 by 1080. I've got all my frame numbers, my X coordinates and my Y coordinates. I'm not going to need the Y for this, but I've got the X's. Back on my spreadsheet, here I've got my frames. Now the camera was shooting for this film 50 frames per second, so I can work out my times. Here are my actual X's, so that's like my displacement. I can work out distance. I know that's pixels per second, but we can later on convert it. The velocity is simply the difference between successive distances, and the acceleration is the difference between successive velocities. Now if I graph raw acceleration it's very jagged, so I'm going to do a trailing average of 50 frames, and that gives me a curve here which, if I were to put a line of best fit on here, would probably be okay. It starts off with a positive acceleration, which would what we would expect taking off from a start line. As we reach maximum speed we've got a zero acceleration. As we slow down we've got a negative acceleration. Velocity starts off at zero, it comes to a maximum as we get flat out, and then it decelerates. And our position or displacement starts at zero, slowly increases, that's flat out, it's the highest gradient, and then slows down. So all that data I'll show you in a series of steps if you want to watch the following videos.